Hey everybody, welcome to the next lesson in counting methods called permutations with distinguishable objects. This will be a short one. It's actually a complete continuation of the last lesson. If you remember the last lesson, we started talking about permutations, and a couple of times you were asked, can you tell the difference between these objects or not, or are they identical or not? And what we learned was a permutation is when order matters, and a distinguishable object just means I can tell the difference between them, nothing too special. So let's try our first example here. It says, again, I'm giving you a deck of cards. We're choosing 4 different cards, and we're going to fill in the chart below. So we did this last lesson, but the difference with this one is this time we're only going to arrange 2 of the 4 that we have in our hand. So let's pretend, again, let's keep our life easy. We got 4 different cards. We got the ace, the jack, the queen, the king. Your job right now is to figure out how many arrangements that you can write down. So I could have the ace and the jack, or the jack and the ace. So you're going to hit pause on the video. You're going to try and figure out how many different arrangements of 2 cards from the 4 cards in your hand that you can make. So go ahead, hit pause, and I'll see you in a couple minutes when you've got all of these listed. Okay, you're back. You've tried to list all 12 of these things. I'm going to try to figure out the other 12 right now. So I've got ace and jack, then I'm going to go ace and king, king and ace. I should have went ace and queen, queen and ace. Then I've got jack and ace already, so then I can go jack and queen, jack and king. So now I've got the jack and all the other cards there. I've got queen and ace already, so let's go queen and jack, queen and king. And so the only thing I'm missing then is king and jack and king and queen. Okay, I don't think I can find any more, so let's just count how many arrangements we have. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I came up with 12 unique arrangements, 12 unique ways that I can order these 2 cards and see them uniquely. Okay, so now that you've got this and you see that there's 12 different arrangements, what I want you to do again is hit pause, and let's see if you can figure out the rest of the questions on this page. See you in a couple minutes. Okay, we're back. Hopefully you had a chance to try all these questions on your own. Let's go through them, see how you did. How many possible arrangements did you find? Well, we found 12. There was no more, no less. Did any of the other groups find more arrangements? Nope, not possible. Okay, do the order of the cards matter? Yes. Again, the reason is I can tell the difference between the order. I can tell the difference. So again, what I'm really trying to say there is if I had an ace in the first spot and a king in the second spot, I can tell the difference if it was a king in the first spot and an ace in the second spot. Do you think that it would make a difference if some of the cards were the same? Yes. If they were identical, so say I had an ace and an ace of clubs and an ace of clubs, I can't tell the difference between these 2 arrangements of the cards. So I'm going to have less examples or less cases for me to consider. How was this different than last class? Well, last class we used all our objects. This class, we're using some of the objects. Not all, some. Okay, does factorial notation give us the correct answer? Okay, this is an important question. So last class, there was 3 cards, I believe, and we would have said, how many ways can I arrange the 3 cards? Well, we would have done this and said 3, 2, 1, which was 6 ways. But if we tried that here for today's class, there was 4 cards. If we tried that today, well, 4, 3, 2, 1, that's going to give us 24, which is clearly not our answer. We've only got 12 different arrangements that we can do. So does factorial notation, which in this question would be 4 factorial, does 4 factorial, which gives us 24, does it give us the correct answer? No. So the reason is because we're not using all 4 of the cards. In fact, if I'm looking at my pretty picture over here, I only want to consider the first 2 cases, which is simply just 4 times 3. That would give us the correct answer. So we can't use factorial notation here because we're not using all of the cards. We're not counting down to times 2 times 1. So does factorial notation give us the correct answer? No, sir. So here comes the important part. When we found the number of possible different distinct arrangements of cards, this is called finding a permutation, meaning order matters. Notice that we did not arrange all of the possible cards for each outcome, but this is still a permutation as order matters. So we can always use fundamental counting principle, but there's a new notation that I want to expose you to here, which is going to make our life a little easier. Now, again, you should have watched the video that shows you how to find this in your calculator and how to put it in. So what this says is I've got a permutation, so that's my P right there, permutation. N says how many objects there are, R is how many I'm using. So for the last question, I would have said order matters, so it's a permutation. There's 4 cards, and I'm using 2 of them. And if you go ahead and take a second to put that in your calculator, guess what? It says 12. So that's a little shorthand way of doing the question. I'd like you to notice that that's the same as going 4 times 3, 12. So permutation notation and fundamental counting principle can give us the same answer. But we're going to see as we get into more complex questions that maybe that permutation notation is going to save us some time. Now, there is a formula for this on my formula sheet, which I need you to know. It goes like this. It says n factorial divided by n minus r factorial. Now, as soon as you see that, you probably go, oh, that looks like some of the stuff he was asking me to do when we were first beginning the unit. That's why. Remember I said you'll see why. We're going to look at that later on. Okay, at the bottom here, often we will prefer to write our permutation using factorial notation or the fundamental counting principle. What I want you to practice as you're trying these is, can I maybe write my answer in more than one way? Now, that was a short little lesson, but I want to do a couple practice questions with you just to kick you off into the practice section. Okay, so Nick here has downloaded 12 of his favorite songs from a completely legal website. How many different 6-song playlists? Okay, I need you to know that that word right there, playlist, means order matters. And I always think of it as at a wedding, right? You want Here Comes the Bride probably at the beginning of the day and not at the end of the day. And you want your YMCA dance song for all the old people to dance to at the end of the night, not at the beginning of the night, right? So order matters. So what this says is he's downloaded 12 songs completely legally, so order matters. This is a permutation. There's 12 objects. I need 6 of them. Now I can put that in my calculator, which I'm going to do. So again, if you don't remember how to do that, I want you to go watch that other video. Look at this. A huge amount of different ways that I could arrange my 6 songs from the 12. Now, like I was saying, writing this in more than one way, this is also 12 times 11 times 10 times 9 times 8 times 7 using fundamental counting principle. Not bad, but a little quicker to write 12p6. Or using my formula, this is 12 factorial over 12 minus 6 factorial, which is 12 factorial over 6 factorial. And you can put that in your calculator. I'm hoping maybe you noticed that's the exact same as that right there. Okay, I'll do one more with you, number 2, and then you're on your own. How many distinct 3-letter arrangements? So arrangement, order matters. Letters in a word, the order always matters because Kraus wants to be called Kraus, not Sarku, right? Kraus wants to be called Kraus. So I go and I look at the word here. It says there's 6 letters in Kraus. I notice they're all unique. None of them are the same. So I say to myself, order matters, permutation. There's 6 letters. I need 3 of them. Bang. This is the same in factorial notation. So I should say fundamental counting principle. There's 6 letters, then 5 letters, then 4 letters. This is the same as using my formula, which is 6 factorial over 6 minus 3 factorial, which is the same as 6 factorial over 3 factorial. And for all of this, that should equal 120. Now, do you have to write your answer in 4 or 5 different ways every time? Absolutely not. What I want you to practice, though, is trying that so that when you see someone else do it in a different way, you can recognize what they're doing. Okay, my friends, the rest of the lessons practice is on you. Good luck. See you next time.